Hello and welcome to another one of your favorite videos, a trig video. This is section 7.5 and today we're going to solve for the missing angle of a right triangle using trig, just like we did use trig to solve for the missing side of a right triangle. You'll notice that a lot of these steps are going to be exactly the same and we're using the same formulas. So let's start out in a familiar place with labeling. Every right triangle has four pieces: the hypotenuse, the opposite and the adjacent side, and the angle of reference theta, which is how we determine which side is opposite and which side is adjacent. To start out, I'm going to use this first example here that we have right below our steps, where you have two side lengths 4 and 12. I like to start by labeling the hypotenuse because it's the side length that always stays in the same spot. Opposite, the right angle is going to be the hypotenuse. Now, we already know that that's 12, so I want to label this with hypotenuse, not its measurement. I like to leave a list so that I know what all four of my labels are, and so out to the side in the margin, I labeled my hypotenuse. Next, I have to look at the angle of reference, which is theta. This angle helps me determine which side is the opposite side and which side is the adjacent side. The angle of reference is always made by two of the three side lengths in a triangle. So, if you've determined where your angle of reference is, you can then identify the two side lengths that actually make up that angle of reference. The hypotenuse will always be a part of theta, so you're always going to highlight that, but it's already the hypotenuse. The second side length that you highlight, that's the adjacent side, because it's the second side length that helps to actually make that angle of reference. The adjacent side in this case, I don't actually know anything about, so I don't know the measurement, I don't know the length, I don't know any of that stuff about it, so I'm just going to go ahead and put a line through it. And that means that I have one more piece of the puzzle to label, and that's going to be the opposite side. So at this point, you'll see I have highlighted two of three sides of the triangle. The only side length that is not highlighted is the opposite side. And in this case, we know that that is a measurement of 4. So step 1 is to use each of the definitions for each of these terms and label each of the terms. And then what we can do is we can identify what pieces of information we do and do not have, because we have 3 different formulas to choose from, but you can only use one. So if you have the opposite side in the hypotenuse, that's going to lead you to the sine formula, the first one I've written in the margin. If you have adjacent and hypotenuse, that's going to lead you to cosine, which is the second formula. And then tangent is going to lead you, or tangent is if you have opposite and adjacent. So that's how you decide, is you have to look at the list of information and determine what do I actually know. I have information about the opposite side and the hypotenuse. That's going to lead me to the sine function. So I know that the sine of theta is equal to the opposite side over the hypotenuse. The next step in this process is to plug in the values that you do know and that you're solving for. So instead of having a generic formula, you actually have numbers and it's the right function that you need to use for the specific problem. You're always going to have to pick a function, you're always going to have to plug something in for theta, and you're always going to have to plug something in for the numerator and the denominator of each fraction. In this case, the left-hand side of the formula doesn't change at all. It's still the sine of theta because the reference, or what we're trying to solve for, is theta. So on the right-hand side, I actually have a complete fraction. The opposite side is 4 and the hypotenuse is 12. If you wanted to simplify this fraction, you definitely could, but there's really no reason to because we're about to use a calculator. So now what you have to do is you have to ask yourself, how am I going to undo a sine, a cosine, or a trig function? Well, we need the opposite. So if the opposite of addition is subtraction, the opposite of sine is going to be inverse sine. The opposite of cosine is going to be inverse cosine. And then the opposite of tangent is going to be inverse tangent. Each one of these functions is going to be something that gets plugged into a calculator. So please make sure that your calculator is handy. What we have to do now is, if we're going to take an inverse, I need to do it on both sides. The idea here is that I need to detach the sine from the theta. So in order for me to do that, I have to take the inverse of the actual function, which is sine. So on each side of the equation, I'm going to take the inverse sine. I have the inverse sine of the sine of theta, which is the left-hand side of the equation. And if I do it to one side, I have to do it to the other side. So now I need to take the inverse sine of the actual fraction of opposite over hypotenuse, which was 4 over 12. So I write my actual fraction without simplifying it, although you could do 1 over 3 if you wanted to. And now, once I have the actual fraction complete, this is ready to go into a calculator. So you'll notice these steps are pretty similar to the steps that we did for solving for a side. It's really just the calculator that makes it a little bit different. At this point, once you have all of your function mapped out and you know what needs to go into the calculator, before you actually put anything in the calculator, please do check and make sure that your calculator is in degrees. And remember here that since we're talking about angles instead of side lengths, this time we're going to go ahead and we're going to round to the nearest whole degree. So you want the next closest whole number. We want the whole degree. And so now, in our calculator, we're ready to figure out what this angle measurement actually is. The idea is that Trig will be able to tell us that if the relationship between the opposite side and the hypotenuse of a right triangle is 4 to 12, that we'll be able to figure out what angle is forming that particular ratio of side lengths. In your calculator, you want to be really careful and you pay attention to if you have a sine to the -1, a cosine to the -1, and a tangent to the -1. That's important because if you just do the sine of 4 over 12, you're going to get an answer in your calculator that doesn't make any sense. So make sure that if you're using a calculator that isn't Desmos, you're probably going to have to do a shift or a second button or something like that. Make sure you ask if you have any calculator questions. I use Desmos, so I first check to make sure my calculator is in degrees, and then I have this wonderful function menu that's going to help me find my inverse sine. I type in my fraction, and you can go ahead and close your parentheses or not, and you end up with 19.47. I told you that we're rounding to the nearest whole degree, so you only look at the one decimal place to the right, so that's 19.4, and I would not round that up, so I'm going to keep that at 19 degrees. So, if you have an opposite side that measures 4 and a hypotenuse that measures 12, you now know that that angle of reference is a 19-degree angle. And if I was a little bit more specific here and I checked opposite, if I do the sine of 19.47, I end up with pretty much the exact same fraction as I would with 4 over 12. So you can kind of see how the angle of reference is related to the relationship of the side lengths in the trig function that you use. Ta-da!